In this video, we're going to take a look at Riemann sums and definite integrals. As we go through this section, we'll talk about what Riemann sums are, and we will get into the definition of a definite integral. All right, so recall from our last video, from the last section, that the area under a curve, it could be computed by taking the limit as the number of rectangles goes to infinity, right? So we looked at these rectangles, we approximated areas under curves by adding up areas of rectangles related to that curve. If we let the number of rectangles head towards infinity, then we're going to get the exact area under that curve. Here, let f be continuous and non-negative on the interval from a to b, the closed interval from a to b. The area of the region bounded by the graph of f and the x-axis and the vertical lines x equals a and x equals b, that area was given by this. Right? Here we're using right-hand endpoints. You could use left-hand endpoints. It would just change how this c is defined. You could use midpoints. It would change how that c is defined. But your delta x would be the same in any of those cases. All right, that is a Riemann sum. So this sum right here, we have a Riemann sum. Great. So sometimes we're going to look at curves that are not entirely above the x-axis, right? So you might have a curve that maybe looks something like this. And so maybe that's our curve. For this curve, maybe we are just interested in the part here. That portion, that would be, we're going to treat that as a positive area. Anything above the x-axis we'll treat as a positive area. And anything below the x-axis, we'll treat that as a negative area. Right? So we have this positive portion. So we're giving a sign to that area. So if it's above, any areas above the x-axis, those are positives. Anything below the x-axis, those would be negative. With that in mind, we can now define a definite integral. So the definition of a definite integral. If f is defined on a closed interval from a to b, and the limit below exists, so this limit right here exists, then f is said to be integrable, right? It's able to be integrated, it's integrable, on that closed interval from a to b, and that limit, we can rewrite that in shorthand in this way. So this is the definite integral. So we could read this as the integral from a to b the integral from a to b of f of x with respect to x. So that's how we might read that. The value a, that comes from your first value in that closed interval. The value b is the second value in that closed interval. F of x, that is our function f. And with respect to x comes from that dx, tells us we are going to integrate this with respect to x. The limit is called the definite integral of f from a to b. That number a, we call that the lower limit of integration. And that value b is the upper limit of integration. And so what we have, you might say, oh, isn't this exactly what we had before? And I would say almost, except for instead of this being just an area, this is now the signed area, or like a net area. So sometimes you have positive values, positive areas, sometimes you have negative areas. All right, so we have this definite integral. This integral from a to b f of x dx, it represents that signed area between the curve y equals f of x and the x-axis on the interval from a to b. So here if we have the integral from 0 to 2 of x cubed minus 1 dx, let's write down, let's draw what this looks like. So as a graph, we have an x cubed graph, but that x cubed graph has been shifted down 1. So it's going to hit there at 1. We will have, if we're going from 0 to 2, right, we're going from 0 to 2, then this integral, it is going to be the green area minus the gold area. Right? Because that gold area is going to ultimately be negative. So if you're thinking of this as an area, a positive value, then you're subtracting that positive area, or you're adding that negative area, however you want to think about that. So we have a negative area down here. Up here above the x-axis, that's positive. Perfect. So that is our definite integral. In our next video, we will look at some properties of definite integrals. We will see you there.